Consider the first order logic sentence. For all x, there exists y such that x is related to y. Assuming non-empty logical domains, which of the sentences below are implied by f? We have been given these 4 statements. They are asking us which of these are true. This is a question from propositional logic. So let's try to solve this question. Let's first consider an example here. Let the domain be the numbers 1, 2 and 3. And suppose the relation R is such that 1 is related to 2, 2 is related to 2 and 3 is related to 3. This is an example which I wrote just now. Now this satisfies this condition. For all x, there exists y such that x is related to y. When x is 1, it is related to 2. When x is 2, it is related to 2. When x is 3, it is related to 3. So the statement saying that for all x, there exists y such that x is related to y is true. Now let's go through these statements. There exists y, there exists x such that x is related to y. So clearly there is one x and one y such that x is related to y. So that seems to be true from this example. Now if we are solving using an example, we can only, if a statement is false, then we can say for 100% sure that that statement will be false. But if that statement is true for this example, we can't say that that statement is always true. So this seems to be true. We'll come back to this later. Let's take an example 2. There exists y such that for all x, x is related to y. So there should be some y such that for all x, x is related to that y. Now if you look, this y is not related to any x, so it is false for y equal to 1. If y equal to 2, then there for all x, x is related to y. So for when x is 1, it is related to 2. When x is 2, it is related to 2. That's fine. But when x is 3, it is not related to 2. So the statement is false for y is 2 as well. If y is 3, clearly x is 1 is not related to that y. So saying that there exists y for all x, x is related to y is false. We got a counter example, so this statement is definitely false. Now let's look at statement 3. For all y, there exists x such that x is related to y. They are saying that whatever y we take, there should be some x which is related to that y. Now clearly when y equal to 1, there is nothing related to this y. So this statement is also false. Now options 2 and 3 is false, so option C and D is eliminated. Only A or B should be correct. Now let's look at the statement 1. It is saying that there exists y, there exists x such that x is related to y. In the question they have given us that for all x, there exists y such that x is related to y. So definitely we can take one x which will be related to some y such that which will be related to some y. So, and they have also given us that we have non-empty logical domain, means there will be at least one x and y which is related to each other. So saying that there exists y, there exists x such that x is related to y is correct. Also statement 4, there doesn't exist any x such that for all y, x is not related to y. Now again that's also true. So if you look at the statement saying that for all x, we can find some y which is related to x, which is same as saying that for none of the x, we will be not able to find some y which is not related to x. I'll repeat that. For all x, there exists y such that x is related to y is same as saying that for there doesn't exist any x which is not related to any y, which is nothing but this statement. There doesn't exist any x for which for all y, x is not related to y. So statement 4 is also correct. These two statements are the same. So the answer is B.